Hello, fellow students. Today we are going to continue working on paths and the accessibility matrix. So stick around and enjoy yourselves. And this is the problem that we are going to work on today, right? We need to consider this graph, the graph in this picture, and this path on it. Right, so let's mark the path in the graph, right? So we start in the first node. We take the link A. We go to the second node. We take B. We go to the third node. We take G. We come back to the third node. We take C. And we go back to the first node. From here, we take D. And we go to the fourth node. And in the fourth node, we take E. And we end up in 2. So the path is something like this. 1, 2, 3, 3 again, 1 again, 4, and 2, right? This is the path. And now we have some questions related to this path and this graph. And the first question is, let me copy it. Right, we need to respond in a reasoned manner, right? Let's write it here. Respond in a reasoned manner. The path C does not give any information about the accessibility matrix because it is not an elemental path. Okay, so is it true that this path does not give any information, right, about the accessibility matrix? Well, I would say that it gives some information indeed, right? Because it says that the second vertex is accessible from 1, right? From the first. Imagine that we didn't have this graph. If we only had this path, we could easily see that the second vertex is accessible from the first. Then the third is accessible from the second and from the first, and like that. So we could see some information about the accessibility matrix, right? Probably not all the information because this is only a graph, a path in the graph, right? There could be many more links, like here. You can see how we don't have any information about F because F is not included in the graph, right? But for the rest of nodes and the rest of links, we have all the information indeed. So the information that we are missing is the direct access from 3 to 4, right? This is the information. This is the information that we are missing, right, on this path regarding the accessibility of the graph. So we can write it down here. This is not true since it gives some information related to the vertices that appear in the path. For instance, the vertex B2 is accessible from B1. Right, it doesn't matter if the path is elemental or simple, because you know, it is not required to give information about the accessibility matrix. Okay, let's go to the next question. If you want to know what is an elemental path, just check the previous video, okay, where it is explained there. The second question is like the position 1, 2 of the accessibility matrix of order 1 is equals to 1, then the position 1, 2 will be 1 for any accessibility matrix. Right, the position 1, 2 is the position that links the node 1 with the node 2, right? And we can see how it is 1 because these nodes are linked by a path of length 1. And as you can see, this already contradicts the first question, right? Because here, again, we have some information, right, related to the accessibility matrix. So what they are asking is, if there is a path of length 1 between 1 and 2, they say that there is a path of any length between 1 and 2. What do you think about this? Think about it, think for yourself about it for 1 second. Does this path guarantee that there is a path of any length from 1 to 2? It doesn't have to, right? For instance, do we have a path of length 2 from 1 to 2? Yes, because we can go through 4, right? And we have a path of length 2 from 1 to 2. So, in fact, this is true, right? For the matrix, accessibility matrix of order 1, the position 1, 2 is 1. For the accessibility matrix of order 2, the position 1, 2 is 1, right? Because I can go from 1 to 4 and then to 2. Here, I can go from 1 to 2. So let's check if there is a path of length 3 from 1 to 2, right? If the accessibility matrix of order 3 has a 1 in the position 1, 2. So is there any way of going from 1 to 2 through a path of length 3? So imagine if first I go to 4, then I only can go to 2, right? If I go to 2, if the other alternative that I have is to go directly to 2, then to 3, and then from 3, I can go back to 2 with one link, with one path of length 1, right? I can't come back to 2, right? So there is no path of length 3 from 1 to 2, right? This is the answer. There is no path of length 3 from 1 to 2. So it is not true the fact that there is a path of length 1 does not guarantee that there is a path of any length, right? More than 1. For instance, there is no path of length 3 from 1 to 2. So the first thing on these questions is that you need to make an effort to read the question and understand what they are asking for, right? Sometimes in the exams and exercise, we get confused because we don't understand quite well what they are asking for, right? This is the first step, to be sure that we read this carefully and we understand what they are asking for. Okay, let's go to the next one. It says, given the path C, we can say that the position 6, the position 1, 2 of the accessibility matrix of order 6 is a 1. So we need to check if 1 and 2 are connected by a path of length 6, right? Let's write it down here. We need to check if the nodes 1 and 2 are connected by a path of length 6, right? That will mean that there is a 1 in that position of the accessibility matrix. So if we come back to the path, we see that the nodes 1 and 2 appear here. Well, I'm not going to take this one into account because this is only length 1, right? So in this case, this is the first vertex of the path, which is B0. And we have 1, 2, 3, 4, 5, 6, right? So this is B6. And this is the node, this is the link 6 also, right? E6, A6. So yeah, the answer is yes, they are connected by a path of length 6 because C is indeed a path of length 6. right? So let's write it here. Yes, the position 1, 2 of the accessibility matrix of order 6 is 1. Because the nodes 1 and 2 are connected by a path of length 6, given that the path C is of length 6. Okay, and what would happen if this path was longer, right? Would the question still be valid? The answer, think about it by yourself. What happens if we have a loop here, right? A loop of length. If we have a loop of length 1 here, right? Or on 3, for instance, what would happen? Think about it, right? We have 1, in fact, right? We have this loop here. So think what happens in this case with the accessibility matrix. Okay, anyway, let's go to the last question. The last question is, we can say that the value in the position 1, 2 of the accessibility matrix is 1, but we cannot say anything related to the accessibility matrix of order 6, since it is not calculated because the directed graph only has 4 vertices. 4 vertices. So here the answer is that the fact that the accessibility matrix of order 6 is not needed, right, to calculate the accessibility matrix doesn't mean that you cannot calculate the accessibility matrix of order 6. Right, in this graph we have 4 vertices. So if we remember, the accessibility matrix was in this case, right? Let's call the graph D, this graph D. So the accessibility matrix is the identity matrix add to the accessibility matrix of order 1, the accessibility matrix of order 2, and the accessibility matrix of order 3, right? And they say that we know the position 1, 2 of this matrix, but we cannot say anything related to M6, right? Because we don't need M6 to calculate the accessibility matrix. And the answer is, this is not true, right? This is fake. This is not true. The fact that the accessibility matrix of order 6 is not needed to calculate the accessibility, the general accessibility matrix, does not mean that you cannot calculate M6. In fact, as we have seen in the previous question, there is a path of length 6 from 1 to 2, which means that the position 1, 2 on the accessibility matrix of order 6 is equals to 1. Right, so okay, this is the answer to all the questions related to this exercise. I will let you a couple of seconds to copy it, and I will stop sharing the screen. So thank you very much for joining me on this lecture today. As always, if you have any question, please don't hesitate to ask down in the comments or write me down. Let me know also if I made any mistake during the talk, and I will correct it in the comments or in the next videos. So thank you very much for joining me today, and see you soon. Ciao, ciao.